Yes, so we'll start with natural language processing. So before this, we have completed with machine learning, few codes like supervised, unsupervised, and then we have seen a little of deep learning, and there we have worked out on regularization, overfitting, all these things, right? So for you, the next topic is natural language processing (NLP). So now today I'll give you a little introduction about it and little basics, and then we'll go to the practicals and everything in that way. Okay, if time permits today, so we'll start with practicals and everything also. If not, we'll start tomorrow the practicals on natural language processing. Okay, so. So first, coming to the introduction to NLP, like definition. So natural language processing (NLP) is a subfield of artificial intelligence. So, as I said, in mathematics you have data science as a subset. In subset of data science you have artificial intelligence, and before we have seen in the subset of machine learning is again for AI. AI subset is machine learning, and deep learning is subset of machine learning. Right now, instead of again like subset of deep learning or machine learning, now AI is having two subsets. Okay, one is machine learning one side, and the other side is NLP, natural language processing. So in that way, two subsets or more subsets are there, but you can, as of now, you can see that two subsets, right? One is machine learning, and inside that deep learning, and here is where NLP. Okay, it's a subfield of artificial intelligence focused on the interaction between the computers and human language. So again, it is like again communication between the human and computer itself, right? In that way, so it involves developing algorithms and models that enables computers to understand. So here, mostly, what should we understand and everything in that way? Making understanding computers and humans also easily is what the main achievement here is, and then interrupt and interpret and also generate human language in a way that both meaningful and useful, right? So now the computers and everything also, instead of just machine learning or binary language, now it will also give the responses and everything in normal language even, right? And where human also can just talk with them computers normally, where it will again decode it, right? In that way. So now NLP encompasses a wide range of tasks and applications. So now after NLP coming into the picture, so there are a lot of possibilities and there are a lot of applications and everything also which are developed. So now from basics text processing to complex language understandings also, the NLP is used. Okay, in that way it is actually made. Then the primary goal of NLP is to enable computers to understand, interrupt and respond to the human language in a valuable way. Okay, in that. Then importance, like NLP is crucial for applications such as translation services, chatbots, sentiment analysis, and information retrieval in that, right? In many ways, it is actually possible. Okay. So now here is like, if you see the goal, right? The primary goal actually is to enable computers to understand, interpret, and respond to the human language, like in a valuable way and everything. Now, if you see the importance also, it is also like translation services, right? Where computer can actually translate into the own languages of human and then explain about it, right? And also whatever human is talking about, so it should understand it. It should again decode it and take it up, right? In that way. Then chatbots, like again voice bots and everything you see, right? In that way, right? Where it will actually again decode everything, whatever is the requirement, and accordingly it will search for it, and again it will give back in that. Then sentiment analysis, like for example, you say get out, right? You say it angrily, and also maybe you can say it. Just give me a minute. Respond to the human language in a valuable way in that. Okay, so yeah, NLP is a crucial for applications such as translation services, chatbot, sentiment analysis, right? So in the sentiment analysis, it will also check whether you're angry, whether you're in what mood, and how you're actually responding to it accordingly, and everything. It will analyze. And also information retrieval. So past data and everything also it will take, and it will actually help you out. Okay. So no, yesterday there was no class. So I think after 26 or something, we're having it today. Sorry, the last class was on 29th, and today again. Okay, yeah. Okay, so NLP, like again, video, text, audio, everything, it is related and it is actually combined with all of them. Then relationship extraction. So you can also, with the natural language processing NLP, it actually through the voice and everything, it can also recognize who is that person. So it's authorized, unauthorized, and then also it'll also make sure like people around and everything, how they're related and how it should be communicating, all these things. Then topic classifications, like again, for example, you have father, mother relation and everything, right? So it actually given you that voice through voice or image or text, whatever, not image, but text or something. It has identified the differences. Now, through the topic classifications, it will also have like, okay, this is another first topic, this second topic. Now, this is relation topic in that way. First topic may be about food, right? It will have all the information related to the food, and it will actually, whenever you ask something, the chatbot also, it will go to the food section and then will check for these answers and then will give you information in that way. Okay. Then raw language processing. For example, any language you take, it will actually convert it to the machine learning language, understandable, and then convert it back to the, it will check the complete library, algorithm, whatever it has and everything. It will again give back to you the processed data in that particular language, right? Then sentiment analysis, even through voice also you can actually detect the sentiments, and also through the image processing, and in that way, right, NLP can actually do that. Entity extraction, like where common points are there, like where whatever is the required intention for getting the output, all these things are also analyzed easily through the NLP, natural language processing. So then if you see the history little bit, so there are many milestones where actually NLP has achieved. In 1950s, like NLP began with the machine translations and computational linguistics and everything, and aligned tunings like Turing test set a milestone for AI, and in that way. 1960s to 70s were development of early NLPs like systems like ELIZA and Shortblue, and focusing on simple text processing and interactions in that. Then 1980s to 1990s were introduction of statistical methods and machine learning algorithms to NLPs, and improving accuracy and efficiency. In that way, it is actually taken care. Then 2000s to present, like advancements in the deep learning and neural networks, revolutionized NLPs, like leading to sophisticated applications also, like BERT, GPT, and large scale language models in that, right? So many NLPs like this, if you can see, it has achieved a lot of milestones and everything, like many places, lot of things for that. It may be old, right? But in picture, you are able to see after AI has become hype, then NLP and all these things are also coming into the picture, right? But many things, if you can see in the history of NLP also, like 1948 it started off, then second is 1950, then in that way AI, ML, deep learning, transforms, ChatGPT 3, and now LLMS. So many things are achieved in that way, right? Then the key concepts of NLP, like syntaxes, if you see, the arrangement of the words and phrases to create well-formed sentences in the language, right? So now the syntaxes in that way, it is creating where each word and everything it takes, each phrases, whatever you are giving, it takes. And then it will actually formulate accordingly. It will check whether you are giving correct or not, whether it is understanding or not, it will check. And then it will give you the correct sentences, corrections also. Spelling mistakes also it will give you, right? In that way, many things. Best possible is like Grammarly. So Grammarly is also one of the tool where it is actually doing that. And semantics, like meaning of the word, phrases, sentence or text. So all these things it will do. In the dictionary, generally you have a word and then a meaning for it, right? In a dictionary. Now, for a sentence and everything also, if you give a complete sentence and everything, it is giving you the recap of like summary of it or recap of it in that way, right? If you give a complete YouTube channel link to an AI tool, now there are many tools like that where it will just summarize the video for you and say you what are the points in that, right? In that way also it is possible. Then discourse, like discourse, the study of the form of the words and how they are constructed. So in that way, it is actually helpful. Then pragmatics, the study of how the context influences the way language is interpreted and all those things, right? So in this way, discourse and pragmatics is also possible. Okay. So discourse, if you see in detail, right, it's again a like beautiful thing, like not how to explain it, like, you know, the study of form of words and how they are constructed even, right? So each word and everything, if you check like two words you combine together, the meaning changes, right? Two words if you take and if you put one before the other, like first one word is it and second one word, then the meaning also changes. If you interchange also, meaning changes, right? So in that way, it will also understand those things also through NLP, right? In that way, and the influence and everything on the language, it will surely understand. Okay. Then the main components which are required for NLP. So now the text processing, if you see, involves cleaning and preparing the text data for analysis. So where whatever texture, everything given, firstly it will just understand what are the required things in that and the keywords and everything it will take and prepare the text data for analysis there, right? And then includes tokenizations, stop word removals, and all these normalizations. For example, tokenization is like again which API you are hitting and how it is actually getting those data and all those things. Then stop word removal, it is like to trigger and also to stop all these things. It will actually use some spaces and also in that way, right? All these things, whatever are there, it will actually do that. Sorry, the text processing. Okay, text processing. It will convert everything into the text. Then the feature extraction, where transform text data into the numerical representations such as TF, IDF, word embeddings, and n-grams in that, right? So each and every feature, right? Everything like extracting and everything you're doing it. So numerical representations, whatever is there, such as TF, IDF, and all those things, right? Word embeddings and n-grams, all these things we have to actually do it. Then model training, like involves training machine learning or models and on process text data and perform specific NLP tasks. All these things are done. Okay. Then evaluation, like assessing the performance of the NLP models, then using metrics like precision, recall, and F1 scores. In that way, you can actually do it. Okay. So now model training and everything also, if feature extraction also, if you see now numerical representations, whatever are there, so it is actually transforming from data into that, right? Such as TFI word embedded in like few examples are given. Now model training, if you see, involves training machine learning models, like whatever models are there which are actually getting trained through the algorithms. Now process text data to perform the specific NLP task. In that way also they are doing it. And now evaluations, like accessing the performance of the NLP models, whatever models are there. So accessing it, like assessing it, sorry. So whether the data is correct or not and how it is performing, accuracy and recall and F1 scores, all these are performed actually on those evaluations. Okay. Yeah, sir. So now the tokenization, right? So now each and every word and everything we take it up, and as we said, right? So it will we'll do all the components also in detail. We'll just check. So now tokenization is a process breaking down into these smaller pieces called tokens. These tokens can be like word, subword, character, or even sentence. This choice of tokens depends on the application and the specific natural language processing NLP task at hand. Now, tokenization is a crucial step in text processing for NLP. where machine learning and deep learning models also, right? So in this way, the tokenization is done. If you see the image, it is so clear that this is a sample. Now, if you apply the tokenization, you are getting it as this as a box, then is as a box, a as a box, and sample as. So it is dividing everything and then giving it to the processing model of it. Then importance here is the tokenization is a first step in the text processing and analysis. Now crucial for understanding the structure and the meaning of the text. Okay, so in that way the tokenization and everything is taken. Now example, natural language processing can be tokenized into natural language and processing. So whatever we have seen in the text here, so you can able to see, right, in that way. Then the stop words, for example, commonly used words such as and, the, is, like any space, all these things that are often removed from the text that improve the processing efficiency. So the normal words and everything are removed so that it will make sure it will do the process faster. Purpose like removing the stop words helps in reducing the noise and also focusing on the important words that are carrying the meaning. So it will actually take what are the actual meaning of it. Right? If we take that complete sentence, what is the actual thing you're getting in that? Now, example in the sentence, the cat sat on the mat, right? So here the stop words are the on can be removed. So leaving like cat, sat, and mat. So in that way, it will understand on its own. Like if you remove the on, it will help with the punctuations and everything. But few stop words are removed at least for the meaning understanding or the processing of it. Okay, in that. We have a question. I think. Just give me a minute. Is that internet issue or okay? Voice. Okay. Maybe I'll come a little closer to the mic. Is that audible now? Is that fine? Am I audible now? Yes. Okay. I think there was some disturbance or something, but yeah, just give me a minute. If not, I'll close the door. Give me a minute. Just give me a minute. I'll be back. 1 minute. Okay. Yes. So let's continue. And if there is any disturbance, also please let me know. Accordingly, I'll make sure the voice and everything is clear. And also, yeah, internet issue also. Please message in the chat. Okay. So now I was just saying about the the components of NLP, where tokenization and everything we discussed, and then we have discussed the stop words also. Right now, stemming and give me a minute. Sorry. Shit. Yeah, sorry. Instead of clicking next, I clicked end. So maybe it got closed due to that. Okay, great. Yeah, so stemming and lemmatization. So now stemming is, sorry, 1 minute, 1 minute. Yes. So stemming, the process of reducing the words to their base or root form, right? And often by removing the suffixes. So for example, like running, it actually becomes run. So in that way, the stemming actually helps to short down the things and then do the processing and so. Now, lemmatization, for example, similar to stemming, but considers the context and transforms the word to their base form as found in the dictionaries. For example, better becomes good. So before, also like whatever similar words and everything are there. So what they do is they just make it simple in that way. So importance, both processes helps in standardizing words and also reducing the variations from easier analysis, right? In that way. Now stemming like rules, for example, generous is like gener, fairly like fairly, right? Sing. So in that way, it will actually make sure it is changing. And lemmatization like generous, fairly, sings, it's more like dictionary itself, whatever is generally there, it is actually using it. Now, part of the speech tagging, right? So, for example, part of speech POS, tagging is a fundamental task in the natural language processing where each word is a text is assigned a part of speech label, right? Such as noun, verb, adjective, etc. All these things are taken care. Now, this process helps in understanding the grammatical structure and meaning of the sentences, which is essential for the various NLP applications. Now, importance like helps in understanding the grammatical structures of sentences and also improves the accuracy of NLP tasks. Example, in the sentence, the quick brown fox jumps over the lazy dog. Here, quick is tagged as an adjective, fox is noun, and jumps as a verb. So, in this way, it will actually understand what exactly is there in the sentence and what is the subject for it, like noun, then verb as what exactly is used, then object, then if it is compound noun, then it will actually modify it and change it, and accordingly, it will use what exactly it is. Like it may be article, adjective, noun, even, and everything. Then again the verb modifier, so how it will be used and in that way. Then the other day, it's actually giving us an again other verb modifier, and where compound adverb is it, the other day in that modifies, right, article, adjective and noun. So in this way, it is completely making the complete sentence into a smaller bits and pieces with the tokenization. Then again, cutting it down wherever required, and then in the complete sentence, it is checking the parts of speech, right? In that way. So named entity recognition, right? In this. Now, named entity recognition, NER, is a crucial task in natural language processing that involves identifying the classifying entities mentioned in the text into predefined categories such as name of the names of the people, organizations, locations, dates, and other specific types of information. The primary goal of NER is to extract structurized information from unstructured text even, which can be used for various applications. So now the definition, if you see here again, the organization or whatever you're giving it out, right? So the main reason for it, like the main why you're classifying it, right? All these things are mentioned. Now it is predefined into very simple things such as name, people or name of people, organizations like locations, dates, and other any type of information. So the type of information is actually tagged, right? So this actually, why we are actually tagging this, why we are actually doing this, right? The primary goal of this is to extract this structured information from an unstructured data, unstructured text. So if you're randomly giving any information, in that it'll just take all these keywords, everything which are tagged, and then we'll actually use that data in that way. Okay. Now importance, like essential for information extraction, like helping to automatically identify the categorized key information of the large text corpora, right? So now whatever is the very large information and everything you're giving it out, so it will actually categorize it, and then it will name the entity, and then it will make sure it is simple in that. Now in the sentence, Barack Obama was born in Hawaii. Now Barack Obama is like identified as a person, then Hawaii as a location. So in that way it is actually taking it up. Okay. So in the picture also you can see that there is a complete text, and organizations is tagged, locations, then dates, then persons, then weapons. In that way it is actually capturing the named entities. All the entities are divided. Now, next is sentiment analysis, right? So, just give me a minute. We have a chat. Okay. Yeah, at the last, I'll also clarify the doubts, or I'll repeat it at the like complete. Also, I'll repeat. Okay, if you're late, no problem. I'll repeat it at the end. Yeah, so next is sentiment analysis. So definition, like sentiment analysis, also known as opinion mining. Okay, so where is a natural language processing technique used to determine the sentiment or emotion tone behind a piece of text. So now it will also understand it. What type of text he has given, like everything in that way. It involves the classifying the text as a positive, negative, or neutral, and can be applied to various forms of communication such as reviews, social media posts, customer feedback, and many more like that. Right. So in that way, and importance is widely used in marketing, customer service, social media monitoring to gauge the people opinion and sentiment. So in that way, it is actually working it out. Now, example, analyzing the customer reviews to determine overall sentiment towards a product, and many things in such. Now, sentiment analysis, like my experience so far has been fantastic. So it is positive, like fantastic keyword is taken. The product is okay, I guess. So okay is like neutral. The support system is useless, like useless is again a negative word there. So in that way, the sentiment and everything is actually analyzed. Now, syntax analysis. So where, wait, okay, I have a question. NLP is applied for, see, it is applied for text also, because see, generally, you're actually, voice and everything also is there, and text is also there. Voice also is converted to text, and then you're doing the analytics there. Okay. So it's finally where you, on the text itself, you will be actually putting up the algorithms and everything and working on it. Okay. In that way, we actually do. So syntax and parsings, right? So syntax, the set of rules that define the structure of the sentences in a language, and also parsing, the process of analyzing a sentence to determine its grammatical structure, and this includes identifying the roles of a word or phrase, words and phrases. Now, importance, like understanding the syntax and phrasing is essential for generating grammatically correct sentences and improving the machine translations. So this is how the complete syntaxes and parsing is happening. For example, if you see in the syntax analysis, 1 plus 2 into 3, right? So first it is cutting down into 1 and plus and into, then 2, 3, in that way it will actually do it, right? So if you again see the definition, the rules that are set to define the structure of a sentence is like syntax, right? And then parsing, like analyzing the sentence with any grammatical structure, like if any grammatical mistakes are there, anything that identifies the roles of that words and phrases is actually parsing. Okay, so it is very important to know about what it is actually, what is the meaning and everything about it. So and then is machine translation, right? So machine translation (MT) is a subfield for natural language processing (NLP) that focuses on automatic translation of the text or speech from one language to the another, and it leverages computational models like algorithms to understand the and generate human languages, aiming to provide accurate and fluent translations in that way. Then approaches like includes rule-based and statistical and neural machine translation methods and neural machine translations powered by deep learning is like most advanced, right? In that way, it is the approaches and everything are taken care. Now, if you see example also like Google Translate is widely used example for machine translation in action. Now, any translator, like from any language to any language, if you see, first it will take the voice, then convert to text. Yeah, sorry. The converted to text, and then it will actually generate into human voice and everything, and it will then convert. Okay. So how accurate it is, how fluent it is, all translations and everything is also taken care with the scores and all those things. Then the last is like speech recognition, even like definition. If you see, speech recognitions, also known as automatic text speech recognizer or text speech to text, right? STT. Now is a technology that enables computers to interpret and then process the human speech into the written text. Now this technology leverages advanced algorithms and machine learning models to convert spoken language into the text, facilitating to applications like voice commands, transcription services, and many conversation agents